Mankind has strived to give lifelike qualities to objects in order to find substitutes which can carry out orders and work. As robots transition into human social environment, a new range of technical, ethical, and legal challenges arise. Different robots use various methods of transport according to their function, components, and structure. In the modern world, there has been an increasing demand for locomotive robots that can access places where men are not capable of going. Small and relative robots are being preferred for narrow and small spaces, since continuous motions like rolling and board taxing require complicated systems to control the motion to adjust to the environment. Discrete motion continues to gain interest for its capability to adapt to the environment, change, and for its simple and ready control. Theo Jansen's mechanism has been known among legged robotic researchers due to its scalable design, energy efficiency, low payload to machine load ratio, and bio-inspired locomotion, allowing adaptation to various terrain. Hence, the researchers designed a prototype named Tetra, terrain traversing machine built for transporting load and monitoring. A four-legged walking robot based on Theo Jansen's linkage principle. It is an innovative concept in robots designed with mechanical and electrical components. It differs from conventional robot design in how the body and legs move, requiring the system to generate an appropriate gait, the pattern of the movement of limbs in animals and humans. It's used for locomotion over a variety of surfaces. The same concept was used to design the movement pattern of the machine on different surfaces. It can travel over different obstacles that come in its path, requiring adequate speed. Among all types of locomotion applied on machines, the legged locomotion is the most suitable system to negotiate rough surface because it has a self-balanced and stable walking pattern.
So for the significance of the study, this project has a great significance and beneficiaries to the following. First is to the explorers. This machine can help them access areas along the exploration that they could not enter anymore. Next one is to the scientists. This project will help them transport dangerous chemical substances which must not be handled with bare hands. Next is to the military. This project will be in great help of keeping eyes on enemies and transporting emergency reliefs and battalion aids across obstacle-littered surfaces. Next is to the students. This study will be in great help of harnessing the innovative competencies while considering the problems of the society. Next is to the university. This project will help the university develop more technologies and ways to solve problems. Next is to the future researchers. This study will give the future researchers essential information and deeper understanding of Theo Jansen mechanism. So for the scope and limitations of this study, the project was centered on constructing a machine involving the Theo Jansen's linkage principle as its planar leg mechanism. The central crank links move in circles as it was actuated by the electric motor, and the crank's motion makes it all the links and pin joints be actuated and succeed its movement.
Methods. This chapter includes the materials used in developing our prototype. The first one are wood sticks. Wooden sticks are used to hold pieces of objects together. Cardboard, a heavy-duty paper-based product having greater thickness, foldability, rigidity, and impact resistance than paper. Connecting wires. It is used to allow electric current to travel from one point on a circuit to another. DC motor is a rotary electric machine that is used to convert direct current electrical energy into mechanical energy. Electrical drill, a drill driven by electric motors, primarily used for making round holes or driving fasteners. Epoxy hardener is a cleared end product of epoxy and used for adhesives. Gears is a set of teeth wheels that are used to work together to alter the relation between the speed of a driving mechanism. The LED is a semiconducting light source that emits light when current flows through it. Paluchino wood is a recycled wood that is strong, rigid, and does not deteriorate easily. Radio control. The use of radio signal transmitted by a radio to remotely control the device. Sandpaper is a paper with abrasive stuck to it used to smoothing and polishing wood surfaces. Screws are used to join things together. The silicone adhesive is a type of adhesive that contains oxygen and silicone that makes it a good water-resistant solution. spray paint, a paint that is contained in an aerosol with the purpose of spraying onto a surface. Super glue is a very strong quick setting adhesive based on cyanoacrylates or similar polymers. And lastly, the 6-volt batteries having a higher voltage capacity, longer usability, and lower discharge rate.
In creating this prototype, we must first prepare all the materials and tools needed in creating this. First, cut out all the parts including the legs, the body, and also the gears. So after cutting all the parts of this, sand each part, especially these gears, to create a firmwork and functional. Next is drill the holes as you see in the joints needed for building this prototype. And in assembling of this prototype, we first do to assemble the body or the chassis, and then install all the parts including the motherboard, the battery, and the motors. Also the LED. And then after installing these parts, we install the gears that are connected to the motor, and then last is the legs. And after assembling, we try this if this is moving accurately, move forward and backward. And after that, we evaluate if this prototype is functional and useful.
For the related literature, there are collections of literary works that present ideas and concepts related to this project. Legged platforms are one of the most versatile design strategies for robot locomotion. Legged robots have its advantages, such as having less energy consumption, having no road requirement, and being capable of crossing obstacles while maintaining its body at a specific height. Butcher explained that legged robot locomotion mechanisms are often inspired by biological systems, which are exceptionally successful in moving through a wide area of harsh environments. For the related studies, there has been a plethora of studies done by the other researchers that are related to our project. The study entitled On a Jansen Leg with Multiple Gate Patterns for Reconfigurable Walking Platforms, conducted by Jansen in 2015, it concluded that the degree of freedom planar provided by Theo Jansen leg mechanisms, which are controlled using a single rotary actuator, provides versatility and energy efficiency given that it utilizes simple gate control. Kormoda et al. Conducted a study entitled A Study of Availability and Extensibility of Theo Jansen Mechanism toward Climbing Over Bumps. The study sought to extend the mechanism from the viewpoint of the number of motion points for climbing movements. This demonstrated the lifting up of the locomotion pattern for climbing purposes. Lastly, the study Dynamic Analysis and Modeling of Jansen Mechanism conducted by Iwasa in 2013 presented dynamic analysis of a four-legged Theo Jansen method. For the conclusion of this study, this project provides a four-legged machine applied with a Theo Jansen mechanism capable of traversing unstructured terrains while having the function of monitoring and carrying load. The machine involves the Theo Jansen's linkage principle as its leg planar mechanism, enabling a smooth walking motion which makes it suitable for irregular terrain. Compared to existing locomotive machines, this machine would help mankind access areas beyond their reach and consequently monitoring and analyzing those unexplored areas.
Yeah. Oh.